Okay, this is our last lesson, and this one is also part of the ideal gas law. You don't have changing conditions again. You can take the original gas law, PV equals nRT, and you can rearrange that equation to create two other equations. And one of them is to solve for molar mass. And the other one, if you take that one, you can solve for density. So in this first equation for molar mass, you can take the mass times the R value times the temperature and divide all of that by the pressure and volume. Mass divided by volume is density, so you can eliminate those two and substitute D in there for density. So you could have density times the R value times the temperature, divide all that by the pressure, and that will give you the molar mass. So we call this the kitty cat equation because it's dirt over P. Or you can rearrange that dirt over P equation and you can solve for density by taking the molar mass, that's the capital letter M, times the pressure, divided by the R value, times the temperature. So let's practice a couple problems with these new equations. Again, this is the ideal gas law. You don't have changing conditions here. So this one, what is the density of a gas at STP? Remember, STP stands for standard temperature and pressure. Standard temperature is 0 degrees Celsius. Standard pressure is either 1 atmosphere, 101.3 kilopascals, 760 millimeters of mercury, or 760 torrs. Any of those are appropriate. I like to use 1 atmosphere because 1 mathematically is very easy to use. So this wants to know what's the density. So the molar mass, the M is molar mass, is 44 for whatever this gas is, grams per mole. The pressure is standard, STP. It doesn't give you a value there. I'm going to make it the 1 atmosphere because I like atmospheres. The temperature is standard. That's the STP again. That's 0 degrees Celsius. So that's 273 Kelvin. The R value, since I used pressure or atmospheres for my pressure, I'm going to use 0.0821. Right, and then we know from the previous slide, the equation to solve for density is that molar mass times the pressure divided by the R value times the temperature. And I know all of that from this problem. So I'm going to take the 44 grams per mole, multiply it by the pressure, which is 1 atmosphere. I'm going to divide those by the R value, and I have to use 0.0821 because I used 1 atmosphere. And I'm going to multiply that by the temperature. Standard temperature is 273 Kelvin. So all of this is going to allow me to solve for the density of the problem. So we go ahead and we plug that in, and we determine the density to be 1.96 grams per liter. So look at your units. The pressure units cancel. The temperature units cancel. The moles cancel. So the only thing you have left are your grams divided by your liters, and that's where your density unit comes from. It's the only thing that doesn't cancel out. So grams per liter is your unit. And let's practice this one here. This one's solving for molar mass. So this one is What is the molar mass of a sample of gas that has a density of 1.09 grams per milliliter at 1.02 atmospheres pressure and 25 degrees Celsius? So, our pressure, 1.02 atmospheres. The density, 1.09 grams per milliliter. The temperature, 25 degrees Celsius, which is 298 Kelvin. What else do we have up there? The R, we're going to need the R value. Since it's in atmospheres for the pressure, 0.0821 is the one that we have to use. So we'll go ahead and I'm looking at this problem and there is a typo in there. This should be grams per liter, not grams per milliliter. So we'll get rid of that. Don't know where that came from. All right, but that's okay. So we'll go ahead and we will solve for molar mass. Molar mass is dirt over P. So we take the density, 1.09 grams per liter. The R value, 0.0821 atmospheres times a liter divided by a mole times a Kelvin times the temperature, 298, and we divide all that by the pressure, which is 1.02 atmospheres. So, and again, this is solving for the molar mass, which is what they're asking for us in this particular problem. So I go ahead and I plug it all in, and I figure out that the molar mass is 26.1 grams per mole. So again, let's look at these units. So the pressure units are going to cancel. The temperature is going to cancel. The volume is going to cancel. So the only units that you have left are your moles and your grams, and those together are going to create your grams per mole for your molar mass. All right, there's another problem here, and this again is to calculate density. So we can go ahead and solve for that. It says calculate the density of a gas will have at STP. So again, standard temperature and pressure if its molar mass is 39.9 grams per mole. So we got 39.9 grams per mole. We're at STP, so standard pressure. Choose one of them. I like 1 atmosphere. Standard temperature is 0 degrees Celsius, so that's 273 Kelvin. The R value is going to be 0.0821. All right, so that's all we're going to need to solve for density. Density, again, is MP over RT. And we know all of this, so we'll plug it in. So 39.9 grams per mole. Pressure, 1 atmosphere. You can use those other pressure units when it's standard. I just like 1. 0.0821. If you use a different pressure unit, then you'll use a different R value, but I'm using atmospheres in my problem. And then we need the temperature, which is 273 Kelvin. So we go ahead and we plug all that stuff in, and we determine, we're looking for the density again here, we determine the density is 1.78 density units, grams per liter. So let's see where those units come from. So the pressures cancel, the temperatures are going to cancel, the moles are going to cancel. So the only thing you have left are your grams and your liters, which is where your density unit comes from because there's nothing to cancel them out. Okay, and that is the end of chapter 14.